Sure, the James Webb Space Telescope is the successor to the Hubble Space Telescope, which is the most successful telescope in history. Webb will be bigger than Hubble and more powerful and be able to see things that are further away. Webb is able to see galaxies that are so far away that the light that those galaxies emitted has traveled for most of the age of the universe to get to our telescope. That means we're seeing light that was emitted just after the Big Bang, when the first stars and galaxies first started to form. Those galaxies then evolved over time to be galaxies like our own Milky Way that we live in. Webb is the successor to the Hubble, but it's not a replacement. We would love to have the two telescopes working together. Hubble works in ultraviolet light, which is bluer than the light that we can see, and invisible light, and maybe a little bit into the near infrared, which is redder than we can see. Webb will pick up with gold-colored light. It absorbs everything bluer than that because the mirrors are actually coated in gold, and reflects red light and infrared light out to where we're seeing the heat from the stars and galaxies in the distant universe. By working together, Hubble and Webb will give us a multicolor picture of the universe. Webb will study exoplanets, which are planets that are in orbit around other stars. And there's a very powerful technique that we can use when the planet goes across the face of its host star and the light from the star goes through the atmosphere of the planet on its way to our telescope. When that happens, we can determine the constituents of that atmosphere, what it's made of, and does it have organic chemistry with molecules like methane and water. So Webb will study planets like gas giant planets like Jupiter and Saturn in our own solar system, but we can also take it down to Earth-like planets, small rocky planets that may even have liquid water on their surface. This is what we think are the conditions for there to be life on other planets. Webb is such a big telescope, 21 feet in diameter, that it's too big to fit inside the rocket that we're launching on. So we have to fold it up like origami or like a transformer. So after the launch, all of the pieces of Webb will fold out in space autonomously. First, a giant tennis court-sized sun shield that protects Webb from the heat and light of the sun. Next, we'll fold out the side wings of the primary mirror and the secondary mirror so that the telescope can work out in space and collect the light from the distant stars and galaxies. This is a huge engineering feat, requiring thousands of engineers working over the years to put this together and to test it to make sure it's all going to work when it's in space. Well, the best way to keep up to date with Webb is to just look at the website nasa.gov. But for the launch itself, you can watch that on NASA TV. And if you're really interested and want to keep up to date with what is happening from day to day after the launch, we have a blog, blogs.nasa.gov/webb, W-E-B-B. I've worked on this telescope in my current capacity since 2002, almost 20 years. When I started working on Webb, my children were little. They were in kindergarten. And now they're going to college and even out of college. So it's a little bit the same way. Working on Webb for that long, I've seen it go from just a design to the hardware, the observatory. I've seen it all put together, and now it's going to be launched. And that's a little bit like sending your kids off to college. You're really excited about what they're going to do with their future, but it's a little bit sad to see it go as well. And that's how I feel about Webb. Really excited about the science it's going to do, but this is a big change in the phase of the project as we go from building it to launching it to using it.